When I say quantum teleportation, your brain probably jumps straight to science fiction, right? You're thinking about beaming people around. But what if I told you the real story here is about the next massive leap for the internet? Seriously, the entire future of our digital world is being built on one of the weirdest, most mind-bending ideas in all of physics. This whole thing kicks off with an idea so bizarre that it famously bugged Albert Einstein himself. He called it spooky action at a distance. What he was talking about was quantum entanglement, and that's the magic ingredient that makes all this possible. And his skepticism is kind of perfect, because it really captures just how strange and wonderful this all is. Okay, so let's get one thing straight right off the bat. This is not Star Trek. We're not beaming people or objects across space. The reality, honestly, is even cooler. We're talking about transferring the exact quantum state, the absolute fundamental identity of a particle from one place to another, instantly. And the particle itself doesn't travel the distance. Think of it like teleporting pure information. And look, this isn't some far-off theory anymore. This is happening right now. In a huge experiment in 2024, scientists at Northwestern University did something that, for a long time, people thought was pretty much impossible. They actually teleported a quantum state through the very same fiber-optic cables that are carrying our everyday internet traffic. This is the breakthrough that just changes the whole game. So how in the world does this spooky action actually work? To really get why this new experiment is such a big deal, we've got to start with the basic physics. So let's dive into the quantum world for a minute. The whole idea hinges on something called quantum entanglement. So imagine you have two particles, let's say photons, that are created together in a very specific way. They become, well, linked, fundamentally connected. If you measure something about one of them, you instantly know the same thing about its partner, even if that partner is on the other side of the galaxy. It's this mysterious, instantaneous connection that just breaks our everyday rules about space and time. Okay, here's a great way to wrap your head around it. Picture a pair of magic coins. You keep one, and you give the other to a friend who flies to Mars. You flip your coin here on Earth, and it lands on heads. The moment it does, you know with absolute certainty that your friend's coin on Mars has just landed on tails. They are forever linked. That instant, perfect connection across any distance, that's the soul of entanglement. So, knowing about this spooky connection is one thing, but how do you actually use it to teleport information? Well, it turns out there's a very precise recipe, a protocol that was actually dreamed up decades before we could even really do it. And believe me, this was a long road. The theory was first put out there back in 1993. 4 years later, in '97, it was proven in a lab. Then the distances started getting bigger and bigger, eventually even going up to satellites in 2017. But here's the catch. All those tests happened in perfect, sterile, isolated conditions. The 2024 breakthrough was the first time it worked in the messy, chaotic, real world of the actual internet. So how do you do it? How do you use entanglement to teleport something? Well, it's like this cosmic recipe with two chefs. We'll call them Alice and Bob. First, they each get one particle from an entangled pair. Now, Alice has a third particle, and she wants to send its state to Bob. What she does is she measures that particle together with her half of the entangled pair. That measurement spits out two regular bits of data, like a 0 and a 1, and she just sends that to Bob over the normal internet. Now, here's the magic. Bob gets those two bits, and they act like an instruction key. They tell him exactly what operation to perform on his entangled particle. And when he does it, poof, his particle transforms into a perfect replica of the one Alice started with. And this is so important. The original is destroyed in Alice's measurement. This isn't a copy machine, it's a true transfer of state. But for years and years, there was this one massive, show-stopping problem that kept this in the lab. Just imagine trying to hear a single delicate whisper in the middle of a screamingly loud rock concert. That's pretty much the challenge that quantum signals were facing. I mean, this was the core question. The classical internet is the rock concert. It's billions of bits of data just shouting down these fiber optic cables. A quantum signal is a single, incredibly fragile photon. That's the whisper. Could that whisper possibly survive all that noise? For a long, long time, almost everyone thought the answer was a hard no. And there's a technical reason for this. The powerful lasers that carry all our internet data, they create a kind of light pollution inside the fiber. It's called Raman scattering. And this noise is like a flood of random light particles that would just completely wash out and destroy that single delicate photon carrying the quantum information. The consensus was you'd need totally separate networks for quantum and classical data. Period. And that is what makes this 2024 experiment so revolutionary. A team took on this so-called impossible problem, and they solved it. They proved that you can hear the whisper over the roar of the concert. And they didn't just do it across a lab bench. They teleported this quantum state over more than 30 kilometers of real-world fiber. I mean, that's a realistic distance for connecting different parts of a city. And get this, they did it while that exact same cable was simultaneously blasting 400 gigabits per second of normal internet traffic. That's like thousands of HD movies streaming at the same time, right alongside that one single fragile quantum whisper. So how did they pull it off? It was just some brilliant, brilliant engineering. They chose very specific colors of light, wavelengths, to keep the quantum and classical signals from stepping on each other's toes. Then they built these incredibly precise filters that could pick out that one single quantum photon from all the background noise. And they used some clever noise cancellation techniques to clean everything up. The result? It was a stunning success. The teleported information arrived with over 90% accuracy. Okay, a successful experiment is fantastic, but so what? What does this actually mean for us, for the future? Well, it means the dream of a quantum internet just got a whole lot more real. This right here, this is the single biggest takeaway from the whole thing. We do not have to build a brand new, separate quantum internet from the ground up. We can use the trillions of dollars of fiber optic cable that is already buried under our cities and oceans. This breakthrough means we can simply upgrade our current network, which makes building a quantum internet way faster, way cheaper, and just vastly more realistic. And the kinds of things this unlocks are absolute game changers. We're talking about truly unhackable communications, guaranteed by the laws of physics. We're talking about the ability to do computations on sensitive data without ever having to decrypt it. Imagine citywide networks of quantum sensors that are so precise they could predict earthquakes or spot diseases earlier than ever. This isn't just an upgrade. This is the foundation for a whole new kind of technology. So, the spooky action that once puzzled Einstein is now being harnessed to run right alongside our Netflix streams. This is not science fiction anymore. A new digital layer is literally being built right on top of the one we already have. The quantum internet is coming. The only question left is, how is it going to change our world?